Good evening, everyone. A warm and pleasant welcome to our respected HOD, distinguished resource persons, faculty colleagues, and all participants joining us to the fourth day of AICT adult sponsored 6 days online faculty development program on smart cities and future mobility, technologies, policies, and practices conducted by Department of Electrical and Electronics Engineering, Mar Basilius Christian College of Engineering and Technology, Peermade. Today's first session will be taken on the highly relevant and futuristic topic application of AI, IoT, and data driven techniques for urban mobility planning. It's my honor to introduce our distinguished resource person and international expert, Dr. S. Albert Alexander Sir, who is the recipient of prestigious Raman Research Fellowship from the University Grants Commission. Dr. S. Albert Alexander Sir is a postdoctoral research fellow from Northeastern University, Boston, Massachusetts, USA. His current research focuses on fault diagnostic system for solar energy conversion system and smart grids. He has 18 years of academic and research experience. He has published 117 technical papers in international and national journals and presented 84 papers at national and international conferences. He has completed 10 funded projects and 3 projects are ongoing with the overall grant amount of 5.03 crores. His PhD works on power quality his PhD work on power quality earned him a national award from ISTE, and he has received 30 awards for his meritorious academic and research career. Young Scientist Award from SPRERI Gujarat, Best Research Award from IEEE Madras Section, etc. He has also received the National Teaching Innovator Award from MHRD Government of India. He is an approved Margadarshak from AICTE Government of India. He is the approved mentor for change under other innovation methods. He is an AICTE approved translator under National Education Policy to translate engineering books into regional language. He has guided 32 graduates and postgraduate projects. 6 research scholars completed their PhD and 5 students are currently pursuing their PhD under his guidance. He is a member and in prestigious positions in various national and international forums. He is the chairman for IEEE Power Electronics Society, IEEE Madras Section. He has been an invited speaker in 330 programs covering 9 Indian states and also at USA. He has organized 25 events, including faculty development programs, workshops, and seminars. He completed his graduate programs in electrical and electronics engineering from Bharatiya University and his postgraduate and PhD programs from Anna University, India. Formerly, he worked as a professor in the Department of Electrical and Electronics Engineering, Kongu Engineering College. Presently, he is working as an associate professor, grade 2 in School of Electrical and Electronics Engineering, Vellore Institute of Technology, Vellore, and also doing research works in artificial intelligence based controllers for power conversion, smart healthcare system, smart grids, solar PV, and power quality improvement techniques. Today, he will be enlightening us on the topic application of AI, IoT, and data driven techniques for urban mobility planning. We are truly honored to have him with us. I invite Dr. S. Albert Alexander Sir to deliver his session and guide us through his expertise. Sir, the stage is yours.
Hello.
Yes, sir. Hello.
Okay, thank you. So whether my screen is visible?
Yes, sir. It is visible.
Okay. Thank you. Thank you so much for the invitation. And I'm very happy and glad to be a part of this Atal FDP. Thanks for all the coordinators for inviting me. So today, the topic which I'm going to deliver here is the application of artificial intelligence, IoT, and data-driven techniques for urban mobility planning for the futuristic EV planning network. Okay, so here I'm going to take the session in the research perspective. So I'm going to give you some problem statements, and I'm also give you some insights about what are the works which we are doing in VIT, and what are the publications which we have made in the area of AI, IoT, and the data-driven techniques, especially for the EV systems and also for the smart grid, smart city planning. So, which is the core of this Atal FDP. So, thank you so much. Let us move on to the today's session. Before going to the session, these are my presentation coverage of today's topic, that is on it covers basically on the electrical vehicles and also on the future mobility system, and how the AI and IoT based systems will be helpful for the battery management, and also the requirements for the calculating the state of health, state of charge, and the depth of discharge, and what are the research opportunities, especially in the AI enabled EV technology. So before I go into the session, let me acknowledge my sponsors. So without whom I would never completed my hardware experiments. So these are my funders: DST, UGC, ASEAN India, and ICMR, and VIT, and my Power Electronics IEEE Society. Okay, so because of their funding only, I can able to do some sort of work in this domain. What I'm going to present today. So these are some of my books which I've written in the area of power electronics and electrical vehicles. So the first book which I'm going to give an exposure for the today's session will be from the extract of the first book. So which will be on the power converters for electrical vehicles, which is also one of the reference book under Anna University curriculum on electrical vehicles. And the second book is also considered for the various universities for their referral, that is for the power electronic converters for the solar PV systems. And the third book will be on the power quality, enhancement of power quality. And fourth one, what we are going to discuss today on the algorithm and the design complexity. And one more thing on the deep learning for the engineers and scientists. And we also made one book on MATLAB for the design and simulation of electrical machines. In addition to that, we also made some book on basic electrical electronics engineering, which is easily downloaded by the AICT website. You can download my book on basic electrical electronics engineering, so which is in the Tamil language. I translated the entire basic electrical electronics engineering in the Tamil. You can easily download the book in the AICT e-Kudum website. In addition to that, I also made some couple of books on instrumentation, and one is on the special electrical machines, which is on my first book. In 2026, in the coming year, my two books will be going to get released. One book will be on the pulse width modulation for control and automation. That's on the PWM techniques. Okay. So which will be released in 2026. And one more book in the 2026 will be on advanced microcontrollers for power electronic applications. Okay. So these are the two books pipeline in the 2026. So which will be released shortly. And when we talk about on the future electrical mobility network, okay, we need to have some kind of theoretical concepts related to that. Are we ready for the EV race in India? Okay, so we want to make some kind of analytical and the economic comparison with China and the US, and we need to make sure that how much we are in the electrical vehicle as far as economic analysis, because this FDP will be speaking about on the future mobility network. But now I'm going to talk about on the what is on the present and what is on the past, of the EV technology. Then only we can think about on the future. Okay, so first we should be very careful about what are the elements in the present EV market. Okay, then only we can think about on the future. Okay, so already whatever the people they think about for the future EV, it is already been available. The people will think about on the physical display of battery management system. It is available. Sensor based IoT for electrical vehicle. It is available. So what for the work? What kind of work which is needed? And how far we can be able to make the conversion of the present vehicles to the electrical vehicles. Normally, when we talk about on the electrical vehicle, it consisting of only three things. Okay, as far as electrical engineers are concerned, we need to focus on only two things. One is on battery, one is on electrical motor, and one is on the power electronic converters. Normally, when you take across some reference from the various so here I speak about power electronics. Okay, so even for the battery and for the power electronics and for the electrical motor, N number of works being done in the areas of AI and also for IoT and also with the data-driven techniques. Okay, so especially for the battery, especially for the power electronics, when you take across many papers which was published earlier, all the papers, it is composed of all these techniques. Okay, for AI based battery life prediction, AI based battery life, that is a fault detection. And for power electronic converters, the people are working with some optimization algorithm, selective harmonic elimination. And for electric motor, a number of papers are available. But now, for the futuristic thing, what are the problems even that is unsolved? Because many of the people, those who are doing the PhD or who are proposed to do the PhD or who have already completed the PhD, or those who are attending the seminar or workshop over here, they should understand initially about the general problem statements first. Okay, and we have to be very clear with the problem statements. And all these problem statements will help you to achieve more number of publications, more number of patents. You see, whenever you ask any students to bring some works, what they will work, they will say that, sir, I'm going to work on battery management system for the final year project. When the people coming across for the PhD, what they will say, sir, I want interested to do with the torque reduction in the electrical motor, and I'm going to work with something on the power electronics, where I'm going to work with on something like harmonic reduction, something like. So only those works are repeated again and again and again. Even the paper that was released in the 2025, it speaks about the general problem that has been discussed over the years. But now, at the end of this particular session, you can able to understand what are the problems we are going to solve. Okay. So actually, these electrical vehicles are broadly classified into basic vehicles or actual vehicles. The steam cars, we know what are the problems. Okay, which needs a water heating and also it needs a more amount of water. What is the problem with the normal IC engines? What we are using now? Initially, it is having some noise and difficulty in the starting, especially through some cold time. Okay, so it's having the difficulty. But now, after the 1912, they have developed the Charles Ketter King. He has developed the starter. So the problem has been solved. But our focus of this workshop will be on the electric cars. What are the problems? One is on the short driving range. For an example, if I charge at Coimbatore, without any trouble, it has to reach Cochin. Okay, so that is my intention. On considering that there is no charging station at the middle. Okay. In addition to that, when the electric vehicle is moving from Coimbatore to Cochin National Highway, we can see that there may be so many ups and downs, and we can also see that there has been so much of road works being done in Thrissur roads. So on how we manage our electrical vehicle through these kind of roads. For an example, let us say if you are going in a Thrissur road, some electrical vehicle got struck. Okay. If a normal vehicle got struck, means what you will do, you will make a tow with a crane and you can make a tow of this particular thing. But the electrical vehicle cannot be towed with the other cranes. Okay. Because of this regenerative phenomena, okay, it will create some catastrophic accident. We cannot make a tow. So what we need to do when an electrical vehicle is not able to move or it got struck, you should not tow the vehicle. Rather than that, what you have to do, you have to carry the vehicle and put it on the crane, and then you have to dispose to the safer place. This problem is not solved even now. Because we know that we assume that none of the electrical vehicle is not struck in the middle of the road. At the middle of the road, because we see that many of the vehicles got stuck at the middle of the road. Okay, so once it got struck, what will happen? Or once it was dashed the median, what will happen? The people will come and they will tow the vehicle and go. But it is not possible for electrical vehicle. You cannot tow it. You have to carry and put it on the crane, and then you have to make to the particular thing. And another problem statement is poor battery performance. So normally we say that we working on the lithium-ion battery. Okay, as a foremost battery which is used predominantly for most of the electrical vehicles. Okay, even now many of the vehicles are used in the lithium ion. But one secret what I want to tell you, so there are two types of energy storage elements are available. One is called as your battery. Okay, the other one what the people now they are talking is called fuel cell. Okay, we know that these two things are energy storage systems. Okay, You should understand that even for a battery or the fuel cell, three major components are needed. What are they? One is called as your anode, one is called as your cathode, and one is called as your electrolyte. Okay, so these are the three major components which is needed for the battery. Normally, the battery works with a redox action. One is called reduction and one is called oxidation. Okay, reduction means it reduces the oxygen atom. Oxidation means it gains one oxygen atom. So one anode or cathode, it performs the function of the reducing and one performs the function of oxidation. So that is the reason we are using this anode and cathode. Okay, so now we are having this anode, cathode, and electrolyte. Now, when we take the names of the battery, always the name of the battery will be on anode and cathode. Okay, what are the materials you're using for anode and cathode? Based upon that only the battery is getting the name. For an example, if you're going for the lithium-ion battery, lithium refers to the anode. Ion refers to the either maybe we call as a lithium ion or else it will be refers to the cathode. Normally, the anode will be always a metal, whereas we can say that the cathode will be always, it will be not a metal. It will be a oxyhalides, halogens kind of. So that is the difference between the battery. When you take across the fuel cell, the names of the fuel cell will not be anode, will not be cathode, whereas the name of the fuel cell will be on the electrolytes. Okay, fuel cell will not get the name as lithium-ion fuel cell. No, the fuel cell names will be based on the type of electrolyte what we are using. That is the first and foremost difference what an engineer should say whenever they come across the difference between the battery and the fuel cell. Battery means it takes the name of the anode and cathode, whereas the fuel cell names are named based upon the name of the electrolyte. So we can say that alkaline fuel cell, proton exchange membrane fuel cell, kind of. Okay, so those things, so that's all the names. So these are some of the definitions what we are going to talk about, because this week, this workshop will be on the electrical vehicle. So why it is got the name as electrical vehicle means because it uses the electrical motors. Here comes a thing, the people will ask, sir, such a basic, everybody will know, but still you should understand the difference between the electrical and the electronics. So whenever the people are studying this core electrical, that is the reason when you talk about the NIT Calicut, they don't have the subject called the electrical electronics course. There is no program on electrical electronics. They have only electrical engineering. So we should know what are the things on electrical. Electrical predominantly speaks about on the power generation, transmission, and distribution. So when we talk about the GTD, one of the element is going to be the motor. So it comes under the category of electrical. Okay, so where the power we speak about on the electrical motor, so it is called as the electrical vehicle, not on the electronics vehicle, because they are called the low power systems. So here these electrical motors are used for propulsion. So when we talk about on the normal IC engine, the IC engine we are having the engine. So now what you're going to do, we replace the engine with the help of the motor. So we call as the electrical vehicle. So now we speak about a future electrical vehicle. Now everybody tells that sorry, electrical vehicle is a new concept. But I want to reiterate that EV is not a new concept. It is nearly 150 years old concept. So we should know whatever the ideas you have in your mind for electrical vehicle, it has been done before 150 years. Even many of my students also are doing their PhD on electrical vehicle. So combining this AI and IoT based techniques, I usually tell them electrical vehicle is 150 years old concept. Okay, it was already a tested, a validated concept. Nobody can claim that EV is a new, because this concept was developed in more than 150 years, even older than transistors. Transistors was developed in the year of 1947, even older than our AI-based techniques. AI-based techniques was started in the year of 1943. Okay, so we can say that these things are started in the year of 1888. This is the year of electrical vehicle. But in 2025, we can say that what the thing which was developed in 1888, that is on the electrical vehicle, we are using the concept of AI that was developed in the 1943, and we are going to develop the hardware with the transistors that is developed in the 1947. So we know that all the components are readily available. 1888 EV is available, 1943 AI is available. Okay, but this AI in 1943, okay, over the period of years, it changes its name. but the essence is same. Name is changing. When it was developed in 1943, the name was just a soft computing rather than hard computing. Then it was travel light in 1954, fuzzy logic. Okay. And in 1974, genetic algorithm by John Holland. Okay. And in 1996, hand-kernel optimization. So it was having some changes by name. And then the people were calling about on the artificial intelligence. Okay, that is, we are going, earlier it was called as artificial neuron. Then they said that they have changed the name as artificial intelligence. Even now, the people they call us AI. So the natural intelligence is mimic, or natural intelligence is being transformed into the form of artificial intelligence. Okay, so natural intelligence means we have all the human beings are having the natural intelligence. So now what we are going to do, we are going to develop a artificial intelligence. That's called AI. But the concept was seeded in the year of 1943. And then over a period of time, what happened? The people are working with AI-based technique. And then they worked with the neural networks. Okay. And then they started to work with the deep learning. Okay. So what is the deep learning? Deep learning means, whenever the hidden neurons are quite additional, we call that as a deep learning. Okay. They call that as a deep learning. That is, whenever the complex problems which was unable to solve by the normal networks, normal neural networks, okay, so they are going to transform that as a deep learning. Everything is a one-line story only. So if you want to complete a course on artificial intelligence and data science, we can able to complete within 1 week. That's all. Within 1 week, you can able to complete the entire course because all the concepts are just one line. Okay, I will tell you what are the one line of each and everything. We know artificial intelligence. It is the mimic of natural intelligence. Second one, when we talk about on the neural networks, it is the network of neurons. Okay, so where we are having the biological neuron in our central nervous system. So that one we are mimicking the software. So we call that as a neural network. Then the people have developed so many algorithms. Okay, and people are working with the back propagation algorithm, Levenberg algorithm, and Cohen algorithm. Okay, and self-organizing maps, adaptive resonance theory. They work with the different algorithms. That's all one of the types of learning methods. And then they shifted to machine learning. Okay. They changed the name as machine learning. What is machine learning? Machine learning means, for example, you have the data, you have the today data. So you have the today is Thursday. You have the data of yesterday. Okay. You have the data of Wednesday. You have the data of Thursday. Using these two, the data, you're going to predict the future. That is called machine learning. You see how simple it is. You're having the data of the past where you're going to predict in the future. That is called machine learning. Prediction, for the purpose of prediction only they develop, and later using the machine learning they went for the data visualization like classification kind of. So that is also one line. If anybody is asking you the definition for machine learning, you give the definition as use the present data, past data, predict the future. That's all. Even for electrical vehicle, how I can use the machine learning? I know the battery today data. I know the data of battery. I know the data of battery in the yesterday. Using the data of yesterday, using the data of today, I'm going to predict the data how the battery will behave for tomorrow. So that's the thing, even for health, I usually tell to my students, to my research students, when we're having the research methodology based classes, I used to tell them that, whenever you're having your health today data, you're having the health yesterday data, based upon that, you need to predict the date in which you're going to die. Okay, so that's what we normally call as a machine learning based prediction. But what many people are doing their research, they download some data from the internet. They download some program from the internet, use the data, putting into the algorithm, and they publish some papers. That is really, according to me, it is quite unethical. Because you cannot say that you contributed something for the particular work. A real work, how you are going to do, you take a normal battery. You take a normal battery and then you connect with the different loads. By varying the loads, you take the voltage and the current profile of the battery during the discharge. Okay. Now you have some data set. The data set is developed by you. The data set is cooked by you. The data set is made by you. Okay. So using those data set, what you're going to do, you're going to make sure with the machine learning, and then you're going to predict. And people, they will ask a question, sir, machine learning and all, we need to learn Python, we need to know coding. Nothing is needed. You just to verify my papers, which I publish in IEEE transactions, I used to only just 5 lines of coding. In all my deep learning based works, whatever I publish in even IEEE transactions, I use just 5 lines of coding to develop a complete machine learning model. Okay, so nobody can claim that machine learning is a course which is entitled to study for 4 years as a BTech course. Nothing. Okay, so because one thing I want to stress, the machine learning algorithms, okay, or the neural network algorithms, initially it was developed by only electrical engineers. Okay, so you should understand that all these algorithms are initially developed by electrical engineers only. You take an algorithm, Adeline algorithm. This Adeline algorithm works basically following the law of Ohm's law. It follows the Ohm's law, and they develop the algorithm. That is called Adeline algorithm. Based upon Adeline, many papers are published for power quality problems. Multiple Adelines are called Medaline. Okay, what is Adeline? Adaptive linear element algorithm. It works basically on the Ohm's law. So we know that in the Ohm's law, okay, based upon the resistance, the current will vary. Okay, so based upon the load current, I need to vary the resistance. So same thing, based upon your input, my voltage, and output, my current, how the resistance is varying. That's my weight sector. So the work what we are proposing for the AI based works is completely a very simple in nature. I will also share some of my case studies later. And after that, the people, they were been talking about an IoT. What is IoT? IoT means it's Internet of Things. Make sure that I'm not moving my slide. I'm just talking only. Don't worry that my slides are got stuck. No, I'm not moving my slides. So IoT means Internet of Things. We all know that what is meant by internet. Okay, internet is there. What is meant by things? Things means anything, any object is called things. You call either as object. You can rename as Internet of Object, IOO, but the name will not fancy. So instead of object, they change to a Internet of Things. Can you give some example for the things? The things are sensors. The things are software. The things are embedded, kind of. Okay. So using these sensors, okay, I'm connecting to the internet for some prediction. That is called IoT. Okay. So I'm taking some kind of data. Okay. So the data collection will be done by my sensors. So the IoT, the first layer is going to be the perception layer. In the perception layer, I'm going to collect the data collection. Then the data will go to the network layer. Okay. I want to transfer the data. I want to give the data to the next layer. So then the next layer, I want to make it for the storage. I want to make it for the communication. I want to make it for the destination part. And the final layer is called as your application layer. In the application layer only, you're going to take some decisions. That's just a simple 3 layers. So the work related to AI or IoT or the data-driven techniques are just a one-line story. But the way how we are going to fixing the problem is required. So in this my session, I'm going to tell some problem statements in EV and how we are going to fix with the help of these tools. Now the people are calling the one more name. That name is called embedded AI and edge AI. Yeah. What is meant by embedded AI and edge AI? Okay, embedded means, that is earlier and all, if you want to connect some devices, some sensors. For an example, in your house, you're keeping some sensors. Okay. And then you have to transfer the data to some other places like IoT. And then you have to come into the client systems. And then you have to take some decisions. Now what happened? Edge AI means, so these are called edge devices. The sensors, the things, the IoT, what we call as a things, here we call as edge devices. Edge devices mean the devices that are connected to the edge of your system, Now the edge of the edge system, let us take one example. Edge devices are sensors. Earlier, what we do, we keep the sensors in the remote location, and after keeping the sensors in the remote location, we transfer the data. And after transferring the data, what we will do, we will take some decisions. But now, what we are going to do, we are sensors and the AI devices will be connected together. So the time taken for transferring the data, the time taken for the storing the data in the cloud, the time taken for the decision will be reduced. So the devices will be connected to your processor, so you can able to take the decision within a minute. That is a subject called embedded AI and edge AI. For this coming semester, I am taking that subject. Okay, so that subject is very interesting. Okay, so where we are talking about on the okay, that is a M processor, ARM layer processor, which we normally call as a Cortex M55 processor. We are going to teach to the students that how we are connecting the edge devices, and edge devices will give the instantaneous data, and collecting the data from then and there itself, how the decision taken. So now what will happen? The IoT is getting older. That's what I'm telling you. In 1943, the history started. And now the people, they are changing the technology one by one by one by one. Even now, if you are talking about IoT and all means, it is all getting outdated. Now IoT is transformed to the next level of edge AI or embedded AI. Okay. That means what? IoT is getting go, because in the IoT there are so many problems. What are the problems they found out? Because they have to collect the data, they have to send the data. If the network is there, the data can be transferred. If the network is not there, the data cannot be transferred, and we cannot retrieve the data. And you need to take the decisions very immediately. That is not possible in the IoT. It will have some delay because of the processing of data from one layer to another layer. So what they've done, the processor is connected very nearer to the are attached to the sensors. So the AI is connected to the edge devices. That is called as edge AI. That is what 2025 we are talking about. And with the future years, even to reduce, they will get across with the other names. So the 1943 to 2025, there has been paradigm shift with each and everything. So year after, when you want to publish a paper or whenever you want to give a project to your students, we want to check, what are the devices are available at present and how we can able to go for the next devices. Even now, I am giving my work, giving the work to my students in the form of quantum. Okay. The people, they will talk about, sir, what is that is a quantum technology, quantum theory. See, quantum means it is basically on the physics laws, fundamental physics laws. Using the physics laws, how I'm going to make for my machine learning to adapt. Actually, machine learning, they follow some algorithms. And now we are going to talk about, how the physics-based quantum, that's we call as a quantum computing. Okay, using the physics laws, basic fundamental physical laws, how am I making my machine learning to be? So I can able to validate that one. So based upon that, so I'm giving most of my works. Even I'm giving some works to my students on quantum batteries. Quantum batteries. That is, how the battery devices can be modeled. Actually, if you search in the internet, there is no physical quantum batteries available. The physical quantum battery is not available. Okay, but still in the research, the thing is that, using, because you can see so much of battery modeling in the internet, but you nowhere see the quantum battery. So we are developing some various batteries with the help of the quantum laws. That is also one of the research problem. So here we talk about some of the examples of the electrical vehicle. Okay, so I think I have not left out any of the history of the AI-based techniques. Okay, I have covered everything. So whenever you have, even we speak about quantum, and then the later it will come across some other computing networks. So it is a continuous process, and it is going to be the continuous systems where we can able to understand that how we are going to talk about on the various things. Okay, so where we can able to understand about where we can able to get multiple ideas in the AI based techniques. So before going to the EV, we have to understand that, the EV's efficiency are more than that of your, the motor efficiency is quite higher than that of the engine. So these are some of the electrical vehicles. So before going to this electrical vehicle, as I already mentioned you, for the next 5 minutes, I will tell you whatever the ideas which you have on electrical vehicle to develop in your institute or to give as a project for your students. You see that how these works are done when the technology is very less, when there is no chat GPT, when there is no Google search, the people have already developed. You see, in the year of 1832, the first crude electrical carriage was developed in British. And then the first practical electrical vehicle was developed in 1835 itself. Okay. So what we are talking about, the concept remains the same. What concept the electrical vehicle is moving at now, the same concept only. The battery, no change in the battery. There is no, what else to say? There is no replacement of the battery. The people will say that, sir, instead of battery, I can use supercapacitor. No, my claim is you cannot use a supercapacitor as a stepney for the battery, because battery has its own phenomena and the supercapacitor has its own phenomena. Supercapacitor can be used only for the three things. It can be useful for the initial starting of the vehicle. It can be used whenever you're climbing the hill, and supercapacitor can be used only when you want a full process of regeneration. Without three things, the supercapacitor role cannot be matched with your normal battery. There is no replacement of the battery. Maybe the people are working with a lithium ion. Sometimes they're working with the sodium magnesium hydrate. Sometimes they're working with other energy storage substance. But the concept of battery remains the same even from 1835 to 2025. There is no replacement of the battery. Okay. So even if you want to analyze, or even if you want to try anything new as an alternate of your battery, I will be explaining you some comparative chart of electric energy storage systems. What is the energy storage systems can be replaced with some other things like a mechanical energy storage, like flywheels, kind of how it can be incorporated. Let us talk about on the electric current using the rails, so which is we normally called as a tram. That was already been available in 1840. And the lead acid battery, what we are talking about on the rechargeable, it was already developed in 1859. And then the design of the battery, the improvisation was developed in 1831. But still now I am seeing so many theses the students are sending to me for the evaluation. I can see that, they are still working on design of battery, mathematical modeling of battery, but it is 1881. But we need to do some improvisations, some novel items. Okay, so the first electric car produced in 1884 in London. So this is the first electric car in Germany in 1888. Okay, you can ask a question, sir. You need to talk about on the future electric vehicle. Yes, we are going to discuss on the future electric vehicle. Other than the design, what changes you can able to do? Other than the type of, so initially you want to know what are the types of motors are used in the conventional vehicles. You need to know what are the types of the battery used in the conventional vehicle. You need to know what are the types of power electronic converters used in the conventional vehicles. Without knowing that, how can we talk about on the futuristic electrical vehicles? So that purpose only I'm giving some kind of inputs on the conventional electrical vehicle, that is on the things have been made. And we talk about on the battery swapping technology. Even when you call across in the Ola Auto service in Chennai, Ola Auto, okay, they will be working on the battery swapping. I can see some people even published some papers. You will check in the Google also. They published some papers in the battery exchange service. Okay, they will swap the battery. Okay, they will come when the battery is drained. They will put in the lot of their discharged battery and take the charged battery and keep it over there. But that technology was already been there in 1896. Okay, so this is what, even at that time, even though there is a lack of infrastructure facility at that particular time, it was there already in the 1896. So the electric cars has been very peak in the 1912, okay, up to the 1912. Okay, and this particular thing, and the electric starter. Okay, so it has made this initially the gasoline-based vehicles. It has made some problem. For the initial starting. So some kind of mechanical force has to be developed for starting those vehicles. But after the invention of this electric starter, that problem is also overcome. So we have to find some kind of about the initial startage, and the Henry Ford has made this Ford company, and that has stopped the electric cars in 1910 itself. So it is just like a small timeline history where the electric vehicle started in 1830 and its story was ended in 1910 itself. But why in 2025 we are talking about electric vehicle? And many people will come and ask the question to me, why the electric vehicle are this much costly than that of IC based vehicles? What changes they have done? They removed the engine and kept one motor. We know what is the price of the motor. What is the price? You just take up a three-phase induction motor. But the thing is that the power rating only speaks the price. Many people will come and argue with me, sir, you take this air conditioner. When you take this air conditioner, you can say that, the people are selling the air conditioner, putting a 5-star rating, and they are saying that it will be for the 40,000 or 45,000 like that. But you open and see the air conditioner, nothing was there. Only a net will be there, some fins will be there, a small motor and the connecting tubes will be there. But it is not costly for the 35,000 to 40,000 for this air conditioner. The same way the people who argue for this electrical vehicle, because since we are the people from the electrical vehicle, we can tell that what is the electric vehicle we are using. The price is not for the components what we are using, because the three major components, one is on the battery, one is on the power electronics, and one is on your motor. The three things are essential things. So that is available, but the power rating. So today I am going to explain you how to calculate the power rating for the electrical vehicle. I'll be explaining you how to calculate the power rating of the electrical vehicle, and then you can able to understand why the price of the electrical vehicle is this much. Because whenever we talk about an electrical vehicle, the normal vehicle, when you purchase this Creta or Kia, it will be within the 20 lakhs. But when you go for the electrical vehicle, it will go for 30 lakhs or 35 lakhs for the better modeling. Okay. So what will be the typical mentality of the Indian mind? So whenever we have the 35 lakhs, we never invest in cars because we know the road condition. Instead of investing that, we'll purchase a normal car for the initial thing. And then we invest those 35 lakhs or 40 lakhs either for gold or either for land, not on the vehicles. Okay. So this particular bottleneck has to be overcome. So in which purpose we can able to do, only when the electrical vehicle prices are getting reduced. Okay, that's the first problem statement. How to reduce the cost of the electrical vehicle. Second problem statement is how we can able to extend so many charging stations. And the third one is how to develop the skilled manpowers in electrical vehicle. The third one is literally a bending in our country, the skilled manpowers. See, whenever you go for any kind of service station, you take your mobile phone. When the mobile phone is not working, what are you going to do? You are taking a mobile phone and going to repair the mobile phone. Whether the person repairs your mobile phone, he will never repair your mobile phone. He will say that your battery has gone, your display has gone, your motherboard has gone. So he is not repairing that one. He replaces that one. That replacement, as an engineer, we can also do. When a mixie is not well, the people are saying that, when it is burnt, not an issue. We have to throw it out. Even when it is not burnt, the people will say that this component has gone. You have to replace it fully. Even for the car also, if you take across any component, they are not repairing. They will say that the entire item has to be purchased and the entire item to be replaced. Then what is the need for a service? In India, we are not doing any kind of service. We are just a replacement. That's what I used to tell them. Even you change the name of the service station as a replacement stations. Just the work is very easier for them also. Okay, they make a profit margin instead of repairing. For repairing, you need more number of technical knowledge. For an example, when the motherboard is not well, when opening the motherboard and what kind of fault has been occurred and how to detect the fault, how to diagnose the fault, that kind of expert level is not available in our country. That's the reason, that is the reason whenever you go and repair any item, they are putting a very big amount of price for repair. Even you take a small television, when a television is repaired, they will say that you purchased a TV for 30,000 or 40,000. So you have to pay the repair price or the service price of 3,000 to 4,000. What he has changed, he changed only a small capacitor. That's all. He changed only a small board. There is no for capacitor burning. You have to replace a new capacitor. How much the cost of the capacitor? It will come just to 20 rupees. Okay, or less than 100 rupees, you will get charged for 3,000 rupees. When you as an electrical engineer, when you argue with him, what he will say, sir, I came from such a long places. So the next time almost he will not come. And even we never have any kind of patience that we can open and see what kind of repair, what is analyzing, what we so nothing we are doing because we are equipped with some other work. So that is the reason, most of the good working components, okay, once it is burnt or once it is broken, we can replace. But once it is repaired, we have to understand why it is repaired. Okay, what is the reason I need to change the components? So nobody is asking. Okay, whenever it is repaired, that's a thing. So here also, so once this electrical vehicle has been closed the history, we want to say that the great car race. This has to be known to many electrical vehicle enthusiasts. Okay, you go and Google it out. This great electric car race. This great electric car race will tell you that the race. The race that was taken between your Boston and California. This race has made the entire world to turn towards this electrical vehicle. The complete race was conducted, and even in India also, the people can try this race, but who will sponsor? Who will sponsor? That's the thing. So here it was sponsored by MIT and also this California Technology. Okay. And this is myself when I visited this MIT campus during my postdoc, where the car race has been started. Okay. And then it has been the revival of the interest. And now we are moving across to the modern EV cars. The first EV cars by Tesla Motors was developed in 2004. It is the first legal production car. The name of the car is Tesla Roadster. The reason why I'm showing this, I have taken a survey of electrical vehicle with respect to battery, with respect to motor. And then I surveyed the problems. Okay, so that's what I'm showing this one. So here this car can able to travel about 320 kilometers with one single charge. And the people will raise the eyebrows and they will ask the question, sir, whether we can able to travel this 320 kilometer in India. No, for Indian roads, it's not possible. Okay, so it was designed for this calculation was made for the American road for the 320 kilometers per charge. Later in Japan, they made Mitsubishi MIV. Chevrolet is a German with a plug-in electrical vehicle. They made for the 64 kilometer, for the single charge. Now I'll be explaining you a great overview about the designing of the power rating of an electrical vehicle. So normally the people, those who study this automobile engineering, this will be the first course. But for electrical students, this may not be the first course. Okay, so let us say that whenever you are going to design a power rating of a electrical vehicle, how to calculate the power. Initially, you need to calculate the total power. Then only you can able to calculate the power requirement provided by your battery. And then only you can able to calculate what is the power of your motor. Okay, so this motor power will tell you the total power of, because the motor is going to be the load. The motor is going to be the load. So this battery and this power electronics, and then this is a motor. So when we talk about on the power rating, I need to calculate the total power. So how to calculate the power rating of an electrical vehicle? For an example, if you want to calculate the motor rating for your industry, you need to calculate the loads, and based upon how many loads and something like that, and what kind of applications the motor is going to do, and what kind of appliance the motor is going to equip with, what you're connecting to the shaft, what kind of mechanical energy you require from the motor. Based upon that, you can design the motor. But for the EV is concerned, the design is totally a different case as far as EV is concerned. So here we want to consider, let us say that we have taken this car. Okay, so let us say that there's a center point of the car. Let us say that this is going to be the mass, and G stands for your gravity. So let us say that here I call this as a straight line. It's called mg. M stands for mass and G stands for gravity. Okay, so mass will be the weight of the car and gravity will be 9.81. And towards this I call as a mg sin theta, and the bottommost I call as a mg cos theta. So this is basically on the center dynamics. Now let us say that the car is moving towards this direction. Okay, so this is the direction of the car. Okay, here I resemble V as the speed. Okay, the V as a speed. So V is speed. So normally in the motor we call N as a speed. So here we use V as a speed. So here is V I call as a velocity at which the car is moving. Okay, so when a car is moving in this direction, there may be three forces that act opposite to the movement of the car. The first force acting is this one. Second force will be window force. And the third one will be MBCCET cos theta. So three forces, they are acting toward opposite to the movement of the electric vehicle. I'm telling about the normal electric vehicle because I'm going to talk about on the power rating of the electrical vehicle. So here we can say that, the three things. I will explain you what will be the first equation. This equation is normally a formula derived from kinetic energy. We know it is half mv square. So here the m I'm going to substitute as a rho into A into CD. That's called the mass, where rho resembles the air density, A resembles the area of the front space, and D is called as a diffraction constant. Okay, so we are having the V square. So here the V square I'm giving as the velocity of the car, okay, minus the opposite velocity, the whole square. So this formula will be on the kinetic energy. First formula. Okay, so this is one of the force that is acting towards the thing. So I want to calculate the power based upon the three forces that is acting on the car. Okay, second one I'm going to talk about on this MBCCET cos theta. Okay. So this RR stands for rolling resistance. So the wheel is rolling, right? So there is rolling resistance constant is CRR cos theta. So we can see the one force, the force that acting in the direction of my movement of the car, I call that as a T, where T stands for traction force. Traction force. See, whenever you are going to design a vehicle, you have to, this is the normal ground. Okay. This is a normal land, So this is a normal land. I'm going to have some theta. Theta means, I can able to, most of the vehicles I'm going to make when the ground. So the ground means when theta is equal to 0 degree. 0 degree. For an example, you are going to climb the electrical vehicle for some certain angle, let us say that 45 degrees. So that angle is also needed if you want to measure the overall power rating of the vehicle. So the overall power rating of the vehicle is obviously needed. Okay, is obviously needed. So whenever we can able to take care of this particular thing. So now we understood that we are having some couple of equations and how this equations plays a thing. So this is the force balance equation of the electrical vehicle. So it's consisting of mass. M stands for mass. Alpha is the angle. Okay, so this is equal to Ft, that's a traction force. There's a force that is acting, Ft is acting towards the movement of your vehicle. Okay, minus summation of your resistive force. There are three number of resistive force are available. So summation of resistive force means, summation means 3. So 1, 2, 3. So 3 resistive force. One is MBCCET cos theta. Okay, the three forces that is acting opposite side of your vehicle. And this is basically on the kinetic energy, what we discussed now, and mg sin theta. So the three forces. So the summation of your resistive forces, I added the first force, second force, and third force, which are acting opposite to the movement of my electrical vehicle. Now I am going to calculate the propulsion force. Propulsion means the force that is needed for the movement of my electrical vehicle. So from this force balance equation, I'm taking the traction force, which we call as a propulsion force. So Ft will be equal to m alpha, this minus will become plus. So m alpha minus will become plus this summation of Fr. The summation of Fr I given over here. So now, based upon these three equations, I can able to calculate the power. Okay, I can able to calculate the power. So this power will help us to drive the vehicle at the speed V. Okay, so what is the power equation? Power equation is given by what is your propulsion force multiplied by your speed. So Ft into V. So for each and every parameter, so m alpha will be included with V. mg cos theta into V. Half into this kinetic energy, I'm including with V. mg sin theta, I'm including with V. So this red color equation will help you to understand what is the power rating which you're going to design for your vehicle. So whenever you're writing a research paper on electrical vehicle, you need to add this dynamics. Okay, so my students, they have done some this same electric vehicle, because in your examiners, they will ask the questions. For an example, you are working with a 30 kilowatt system, they will ask you why you use the 30 kilowatt system for electric vehicle. See, whatever the work which you're doing in the electric vehicle, any paper you can see that the work will be for the 80 kilowatt. Okay, and then 30 kilowatt rating. So you can see that, for the two-wheelers, they go for nearly across about 30 kilowatt. For the four-wheelers, it will be 80 kilowatt. I will show you what is the rating of this Tesla, and I also show the rating of this Mitsubishi. You can see that, those rating will be 80 kilowatt and 30 kilowatt. And then you remember that for 30 kilowatt system, what kind of power electronic converters has to be developed. What converters we are going to use? Normally, the people they are using for the final year project, what power electronic converters they are using? They are using at that 300 volt MOSFET and then 5 amps. So normally, you can able to see that, it will be only about 1500 watts. Okay, 1.5 kilowatt. 1.5 kilowatts which you are using, but we need a system that takes care of 30 kilowatt. So that is the reason, the people, they are switching with the silicon carbide and the gallium nitride devices. Why? Because to handle this 30 kilowatt, to handle this 80 kilowatt. So now you can able to understand that, why the electrical vehicle, which is having this much of high rating capacity, because it follows the three equations. Based upon these equations, the final outcome is nearly, it will be greater than 30 kilowatt only. Okay, so to make much more understandable for participants, I have taken one sample power calculation. Okay, so these calculations in detail, it is also available in my book also. And for your understanding, I'm going to give you the power calculation. So let us say that the mass is going to be 1000 kg and the speed will be for 100 kilometer per hour. Okay, so for this particular thing, as I already mentioned you that, that is whatever the things which we can able to get along with the things, so whatever the okay, so whatever the items which we are discussed till now, this is a formula to calculate the power rating. So these are the values which we can able to assume. For an example, whenever I'm taking the subject on this electrical vehicle, for my question paper, I used to give the students with a different thing, for the different alpha, for the different rolling resistance, for the different kind of air density and alpha, the area. So the people has to calculate the total maximum power rating. Because every electrical engineer is to understand the power rating calculation of electrical vehicle. Because we can question that why the electrical vehicle are more than 30 kilowatt, 40 kilowatt, 50 kilowatt. Because when I am doing PhD, my overall system, what I have done is only for 3 kilowatt. I did my PhD on the power quality analysis for the inverter. So the system, the overall system, what I developed is just 3 kilowatt. You cannot make use of a 3 kilowatt and show that for an electrical vehicle, especially for the four-wheelers. Even for two-wheelers, maybe the mass will be quite reduced. Mass will be reduced for the two-wheelers. But the thing is that, the calculation we have to understand. So I've taken the mass as 1000. Let us take the alpha is equal to 0. It's a tire deformation constant angle. That is, initially the alpha is equal to 0. That is, you consider that it is a brand new. Mass is 1000. And then G, gravity is equal to 9.81. CRR is 0.02. That's a rolling resistance. Cos theta. So theta, I have taken as 0. So cos theta is equal to 1. Okay. And then half is 0.5. Rho, air density is 1.2 kg per meter cube. Area is 2 meters square. And then the diffraction constant is CD is 0.5. V minus VW. What is V? Velocity. Velocity speed is equal to 100 kilometer. 100 minus VW, I have taken as 0. So 100 minus 0, the whole square. So I have taken as a 100 square. 100 square. So this 100 square, when I was converting into the meters per second, kilometer per hour is converted to meters per second. 100 into 5 divided by 18. So you will get the value as 28. So instead of 100 square, we are using this 28 square because this kilometer per hour is converted into meters per second. and then mg sine theta. So m is 1000, gravity is sine theta, sine 0 is 0. So this function will be equal to 0, and this velocity I have taken as 100, the speed is 100 kilometer per hour, converting into meters per second is 28. So I'm getting the total power rating of 31 kilowatt. So this is the total rating of your vehicle. Now you can able to understand that, if you know the weight of the vehicle, and if you know the speed of the vehicle, you can able to calculate, and you can able to understand about various things. Okay, you can able to find out the various mechanisms related to that. So by this, we are ending the power calculation of your vehicle. For an example, if you have some additional requirement, that is, you want to have some initial acceleration, that is initial acceleration of your vehicle from 0 to 100 kilometer per hour in 10 seconds. That is your initial requirement. That is for the initial starting. You want to go for the 0 to 100 kilometer per hour in 10 seconds. That is this is an add-on. You want to add on this one. So I'm going to make the power calculation, which is equal to mass. Okay. And then what we are going to do, I'm making the 10 seconds into this one, that is converting into meters per second. And then this particular thing, the half of 28, which is going to be a 14. So I can able to get this 38 kilowatt. So now if you want this add on, what is going to happen? 31 plus 38, I'm getting this 69 kilowatt. So I want to prove this, why your EV is having 69 kilowatt. I have taken one comparative analysis. Let us have a quick run of this comparative analysis. You see, first you see about the Nissan Leaf. Okay, in the Nissan Leaf, I'm taking the comparison of the powertrain. You see, the motor rating is 80 kilowatt. This is the reason, why these vehicles are quite costlier, because of 80 kilowatt, So our calculation is for general thing, normal 69 kilowatt. But here they made the calculation of 80 kilowatt. So this rating, this higher, then you can able to understand for this rating, how much of power electronic interface is needed. Okay. And the battery, normally we have made analysis that they're using the lithium ion battery. Okay. So normally powertrain consisting of electrical motor, battery, transmission. Transmission means from the motor, how your it's connected to your wheels, and what is the range. Okay, so range means for a single charge how this vehicle are going, and what is when we plug in charging. So what kind of adapters it is required to make this vehicle to be get charged from the grid, or when you do make different kind of sockets. When you go for the Ford Focus, you can see it is about 107 kilowatt. Battery is again lithium ion battery. When you take across BMW i3 vehicle, the electric vehicle motor is 125 kilowatt. So you should understand that this 123 kilowatt has been made based upon the calculations what we have done now. Okay, and also the battery, again the lithium ion battery. Okay, and we go across the Chevrolet Volt. So this vehicle, the electrical motor is PM, permanent magnet motor generator set, and also the engine is going to be a 63 kilowatt. So whenever you come across these many kind of rating, always you understand that we are having only 4 formulas. You substitute in the 4 formulas to get your corresponding output. So this is my favorite, what I want interested to show, that is called the Tesla. Okay, so normally this Tesla is quite costly, because you can able to understand that normally it consisting of 2 things. So the electric motor, so it consisting of 3-phase AC induction motor. So whenever I'm teaching this AC induction motor, the first application what I show before I'm teaching them the principle of a 3-phase induction motor, I'm principle of this particular thing, kind of, and also telling squirrel gate, slip ring types, external resistance. So before I show, to make the students to get more interest about this 3-phase induction motor, this Tesla S vehicle. Okay, and also the battery rating, the 75 kWh. 85 kWh or 90 kWh. So that depends upon the battery rating will be basically it will be around 75 to 100 kWh. It has been done based upon the range, what is needed. And also the different kind of charger, fast charger, onboard charger and offboard charger. And Mitsubishi also, we can say that is about 47 kilowatt, because you can see the size of the vehicle is quite less when compared to the earlier. So that is the reason the electric motor is 47 kilowatt. And also the battery is again lithium ion battery. And then we have made another set of comparison. Okay, just to skip these things. Okay, fine. There are 2 different types of charging. One is called the slow charging, one is called the fast charging. So the people, they are quite working with on the fast charging. Okay, fast charging means it is also called as a DC charger. Fast charger is a DC charger. Okay, so that is the reason we are using the battery, where it can be stored the battery, and then we can, for this particular thing, it will be charged in 30 minutes to 2 hours. So we can say that DC charging is a fast charging, but it requires a more number of infrastructure cost, and the impact of battery life is quite large. Slow charging is also called as a AC charging pile or it's onboard charging, which effectively takes about 6 to 10 hours the charging duration, and the infrastructure cost is low. So whenever a normal charging mode comparison between slow and fast, we need to have this kind of comparative analysis. And these things I already mentioned you about the battery swapping, how the Vola Auto, they are doing this thing. And this is one of the important classification what everybody need to know about the different set of batteries, or it has been useful for the electrical vehicle. So normally we are using the electrochemical. Okay, so we normal for the as far as electrical vehicle is concerned, we are using across a lithium ion, sodium ion, nickel magnesium hydride, nickel cadmium. Okay, so all these things, it's an anode and cathode, anode and cathode, anode and cathode kind of, and flow batteries like zinc and bromine batteries. Okay, thermal kind of classification means, now the people are working. It's all basically on the research side, not on the practical arena. So the molten salt and the hot things and smart electrical. Mechanical based systems, the premier thing is flywheels and adiabatic and the diabetic compressed air. Electrical means, we know the capacitor is a storage element. Chemical means, the hydrogen, what we normally use in the full fuel cell. So the energy storage system general classification for EV is concerned, we are using focus on electrochemical, we focus on chemical for fuel cells. Okay, and then I just to move with another set of comparison with the help of batteries used in the various EV. So we made some various kind of models of electrical vehicles. We have seen that most of the battery, they use the lithium ion only. Some cases they are using a nickel magnesium hydride. Okay, so most of the cases the lithium ion plays a predominant role. And then I can able to move across. These are the different EVs today. Okay. Okay. So my presentation is not completed yet. Now we have understood about something related to the electrical vehicle. Now let us move on to the AI driven techniques. Okay. We understood what are the general problems and general things, So here let us talk about for the, because now the time is 7:10. So I will complete by 7:25 and some time in 10 minutes. I want to make a quick refresh on this algorithms, especially for EV is concerned. Okay, so normally, when we talk about on the comparative analysis of AI based techniques, as I already mentioned you, AI is going to mimic the human brain, and machine learning, because it learns from data, and deep learning means, it mimics the human brain, and also it incorporates the intelligence into machine. So all are subsets. So we are making so much of research papers in machine learning and deep learning with the various algorithms. Normally, we know this all works basically on the biological inspiration. There's a learning networks, and this is the way how the learning takes place in our biological neuron. Okay, so how whenever we think something, we do something, this is the reactions that takes place in our thing. So this reaction we normally call as a learning. This is a general reaction we call as a learning. Okay, so that's what we talk about on the machine learning, deep learning, and all these algorithms we can implement using the embedded AI and edge AI for the real-time applications. Okay, so this is a thing. So the history of this particular networks means started in the 1943, and even now the people they are working with network and various algorithms being developed various years, back propagation, perceptron, and all such a different kind of algorithms for solving. So these are, see, whenever one particular student, he came to me and asked me, sir, what PhD work I can do? I just showed this slide and this slide, that's all. This one and this one. These two slides I showed. You take one small problem, but the problem statement what I've given is power quality problem. Okay, that is a reduction of power quality in the inverter problem. And I asked him to implement all these algorithms. You implement all these algorithms. And then you make a comparative analysis of all these algorithms and prepare a paper. That paper was accepted and published in IEEE Access. If anybody is interested, I can share the paper as well. Even for this battery or EV based systems, you take one simple general problem and then you apply all these algorithms one by one. You can ask a question, sir, how much time it will take for implementing all these algorithms? When you're going for the MATLAB, if you're implementing even a single algorithm, it will take not more than 20 minutes to implement. Okay, so you can make a comparative analysis between all the algorithms. You can make even a 2 volume of thesis. Okay, so you can get a complete idea of learning methods and also complete idea of the EV as well. But many a times what people are doing, they're doing the research by implementing any one algorithm and then completing their work. That is not at all I won't consider that as a research. If you're doing any one particular work, you need to do the n number of algorithms, and finally only you have to show which algorithm is best. Just to compare, just to doing some 2 algorithms, some PI based algorithm, PI based controller, neural controller, fuzzy controller, and comparing these 3, I am telling that fuzzy is best. That is not at all a thing. We have to go for the n number of models, n number of algorithms, and finally only for this particular work, which algorithm is suited, not 2 or 3. So based upon that, even a week, every week you can publish one Scopus paper. Every week, the people will ask me, sir, how you are publishing more number of papers? I usually tell them, the major item is you take one small research problem. For that particular research problem, you understand the problem very well and try to implement these learning algorithms one by one. Based upon that, you can cook up any n number of papers. So these are some of the algorithms, what we have developed and what we have done for this battery management systems. And now we don't have time to explain. But anyway, I will be explaining one kind of algorithm that what we've done for this, okay, for this battery systems. So now the people, they are working with the LSTM. Okay, so long and the short term memory storage. Okay, so long term memory. Okay, so where the people, they're creating this AI based methods for LSTM for the prediction modeling, because this presentation what I'm showing you, which consisting of the different algorithms and how we develop these algorithms and proven mathematically, and how these algorithms been implemented in the real time. So for an example, when we talk about on the LSTM, okay, so how the data sets are we are taking, what is the role of this TANH as an activation function to provide the results? Okay, but anyway, we don't have enough time to explain this one. But anyway, so that is how the data set is coming, how the data set is divided into 2 in the mathematical model, how it is added, and what is the role of TANH, and how that because all this data are resembling, and finally the C of T we are getting. C of T and H of T. So that is my overall items. So that is called as finally I want to get H of T, C of T, and H of T. Okay. So for the given data set, this is called the LSTM. So recently we made a few articles in the LSTM. Okay. So, but we explain this thing, so the process is simple. So there is a T minus 1 means what is the previous data? T means the present data. So each and everything, there is a X and sigma and the TANH, each performs a function of converting that into some realistic, what else to say, for decision taking systems. Okay. And we made some kind of numerical problems also with LSTM. And if anybody interested, I can share this one. If you keep on interested for the LSTM, we solve the mathematical problem for the LSTM also. And all this LSTM, and this is another version of LSTM. That's a gated recurrent unit. What this is another set of things what we have done. Okay, so I think now we can open for questions and sessions. For the next 10 minutes, we can have some questions. I can see some questions. No, I can see only the attendance forms are there. Normally, as I already mentioned you, a simple research problems over there in the machine problems in the battery management system and the smart grid. The problems what we are taking Okay, I can also show you some of the papers later, but if I show it, will take some more time because I want to be justice. Because if I show means I want to explain one by one. So if anybody is interested, I can share my recent papers on EV with AI and IoT. So if you have any questions, you can post it in the chat box or you can ask the questions. Anybody is there?
Yes, sir. Participants may ask any queries about the session. Sir will explain it. If you have to ask in the chat box, that you can be.
Good evening, sir. Sir,
Yes,
my
ma'am.
name is Srini. I have heard nowadays many people are focusing on research on fuel cells. Can you just
Okay.
give us an idea where to work on? What are the recent advancements?
Okay, ma'am. Sure. I will just now. I will share my screen. Okay. Since you
Okay.
asked about on the fuel cell.
Yes, sir.
Okay, so I can show that. See, actually, whenever we work on this fuel cell, okay, so here we can say that, the fuel cell consisting of various types. So, as I already mentioned you at the starting of our presentation itself, the fuel cell is identified by only on the electrolyte because this electrolyte will determine the temperature. Okay, and here these are the focus points of fuel cell like alkaline, PEM fuel cell, phosphoric fuel cell, molten carbon fuel cell, and solid oxide fuel cell. So here the work is very simple. That is, when we talk about on the water consisting of hydrogen and oxygen. So that is hydrogen plus oxygen will give you the water. But what we are going to do, we take the water and separate this hydrogen and oxygen. Okay. So let us say that, this hydrogen will be considered as a fuel for the fuel cell. So what does the fuel cell means? Let us talk about on the alkaline fuel cell. So here the alkaline means that is potassium hydroxide is alkaline. So this is acting as an electrolyte. So since the potassium hydroxide is acting as an electrolyte, so we can call this as alkaline fuel cell. So the hydrogen is coming inside and it is given to the porous anode and the porous cathode, we are this is a cathode. Okay. So this is going to be the oxygen. So hydrogen, oxygen, and this is the positive and negative terminals we are connected to the load. That's all. But most of the institutes, what they are doing, they will be having some 3 cylinders, okay, in their lab consisting of hydrogen and sulfur or something like that. And then they say that this is our work kind of. But maximum they when I was working with, because in my earlier institute I had my own fuel cell test bed. Maximum I can generate only 2.8 volts, man. That's all. Maximum I can generate. But we know what is the process. For an example, in the normal battery, the anode will be made up of metal. But here, this anode will be given. So the one of the advantage of the fuel cell is as long as you are supplying this hydrogen, my load will be get energized. When you stop this hydrogen, the load will be get stopped. That's the thing. Okay. This is the normal working of a alkaline fuel cell. So as I already mentioned you that this is combined with hydrogen forms of water and some kind of fuel cell. What will happen, so when we talk about on this hydrogen you're giving, oxygen you're giving, and some cases they're having also the possibility that where you can able to get the water. Okay, water is also released. So the two things you can able to get from the fuel cell, one is on the electricity to the load, one is on the water. Okay, so the anode, what you're going to do, the hydrogen gas, it will react to the hydroxide ions present in the electrolyte to form water, and the electrons are released. So two things are happening. One is produces the water, and also the electrons are released for powering this particular load. This is for the alkaline fuel cell. Okay, and similarly here this is one of the popular fuels that we call as a proton. It's not proton, it's a proton exchange. We call as a proton exchange membrane fuel cell. Okay, so here we can say that for the anode, we are giving this hydrogen. So this hydrogen will be released in the form of 4H plus 4E minus. So this 4E minus will be, this electron is given to the load. Now what is happening? We are having this ion exchange membrane. So that will acting as an electrolyte. So electrolyte will be there between your anode and cathode. So from the cathode, what I'm going to do, I'm giving the oxygen, and this 4, it will be reacting with this 4H and reacting with this 4E, and it will give the water. Okay, so if you don't want the water, you no need to give the oxygen. Okay, so you will not get water. This is an additional thing. If you need water, this option is okay. So mostly this particular fuel cell only many peoples are using, even for their research work and all. But the working process is very simple. That is, we are giving for the anode, we are giving the hydrogen, and then how it powers my load and how the reaction takes place in the cathode along with oxygen and releases the water. That's for the fuel cell. But now the problem is, this is okay at this particular part. The problem is here. Okay. The first question is, how will you generate the hydrogen? People will say that, sir, there are so many methods like a pyrolysis, electrolysis, everything is there. So you can able to generate the hydrogen. Problem number 2 is, how will you store the hydrogen? Problem number 3 is, how will you transport the hydrogen? Problem number 4 is, how will you measure the hydrogen? Even we can say that, hydrogen is the first element in the chemistry lookup table, but the advantage of hydrogen is more. As equal to our oxygen and carbon dioxide, hydrogen plays a very important role. So that is the reason, now the people are talking about hydrogen powered car, hydrogen vehicle, everything, because hydrogen is having that much of tendency because of its valence electrons. So that is the reason we are here. The fuel cell means the fuel itself is a hydrogen. But these are the problems are associated with the fuel cell. But in the MATLAB, you can able to simulate. Okay, there are so many options are available in our MATLAB where you can able to simulate this particular thing, where you can able to get more number of results. But in the hardware, this is available in the manufacturers. They will deliver this one. But when the manufacturer delivered, what we learn from that, nothing we learn. So they will give us a plug and play. They will give a cylinder. You want one light will glow, one LED will glow, or else that is the group of LEDs. I'm not a single group of LEDs, and you can have some display. That's all. But here the problem is we have to analyze or assess these chemical reactions. That's what whenever I'm talking to my students, I usually tell, even for the battery, we want to create a battery scanner. Okay, or else whatever the chemical reaction takes place inside the battery, I want to have a display of the chemical reactions outside. Till now there is no equipment is available. Okay, because we want to know what kind of reactions takes place. So I can display the values. So sensor, it will take the voltage or current and display as a 12 volt, 6 volt kind of. But I want a display where it will show the reaction that takes place internal periphery of this particular thing. That is no way available. That's not present. I can give you this problem statement the people can think of, and we can able to discuss. And there are various kind of other fuel cells also. Molten carbonate fuel cell. That is, molten carbonate means along with the hydrogen, I will also give the molten carbon monoxide. Okay, and then the molten carbon monoxide these two things will give the load. If you want the water, I can give the oxygen. So this element will be given, and I can get the water as a steam plus carbon dioxide. These are the types. These are the basic types of fuel cell what we normally work with.
Sir, is there any simulation softwares like to show this what is happening inside it?
No, ma'am. No.
Okay.
That is not available. That's not available. That's what I'm telling. If anything is available, even I'm trying. I'm asked the students also to create something, but they'll be coming and they will say that, sir, I'm having placement, that, this, and all. But this problem statement, if anybody is doing, means it will be a great thing. The same technology you can even continue for human health analysis also.
Okay.
So initially, if you are working with a battery, the later we can work for the human body also. We can analyze what is happening inside. Many people don't know what is happening inside. That is the biggest problem. What earlier, later stage of cancer, they are going for the treatment. But at the beginning stage, we want to understand what is happening. Okay, so
Okay.
for that purpose only, because as you asked, ma'am, there will be some thermal scanners are available. The thermal scanners, what you can, it will show only the some colored illusion kind of. But I want a precise thing, precise reaction. Okay, I want to understand how many cells are taking part in the reaction. I want to see what is inside happening inside the battery, whether all the cells are operating, whether all the cells are equally taking part in the chemical reaction, how many cells are idle. That information nobody knows.
Okay, sir. Thank you, sir.
How can we learn various algorithms of ANN? See, algorithm is nothing. Algorithm is it's a learning types. That's all. Okay, so no need to learn the algorithms. I recommend you to formulate the algorithms. We should, because nowadays people, the researchers, what they are doing, some people have done back propagation algorithm, you are doing the back no need to do that. You just make some changes in the algorithm and you can give the name of your name for the algorithm. What is the role of algorithm? Algorithm is, it is used for training your data. So whenever giving some input for the supervised or the target data, based upon your input and target, so where we can able to understand, based upon that, the learning can be initialized. That is called the training. Okay, so the learning algorithms, even you can watch my videos. I will discuss some various algorithms also. You can visit my website and you can watch my videos where I for the school students also, I've given some inputs of learning some initial algorithms. Algorithm is very simple, sir. For an example, when a mother is teaching the kid how to eat the food, okay, some mother will beat the kid. Some mother will beg the kid, please eat the food. Some mother, what they will do, they will compare with other kids. See, that kid is eating like that. So whatever the steps they are doing, that is called algorithms. It does not mean that I should follow the mother. She's doing that. Okay, I should also follow the same thing to make my kid to eat. Not like that. You can follow your own methodology also, because that is their kid. This is your kid. Okay, so you know about the kid parameters. So based upon the kid parameters, what are the things your kid will like? Based upon that, you can feed them. You can teach them how to eat of their own. That's the difference. So they worked with another some data set, means they work for their application. They work for their country. Okay. So they use some algorithm. So for us, for our system, how we are going to do. So it's very simple only. It will require just 1 day is enough for reading the complete thing. Wireless charging concept prevalent in India or not in EV? Yeah, it is not prevalent. It's only in the research for the things, for wireless concept, especially in the laboratory wise, the wireless concept is there. The two for the limited distance. What is wireless concept? We are using some two inductant coil and then making the so that side connected to source, this side connected to load. So in between, how this inductance is transferring its charges to the another subsequent inductance. That's called the inductance wireless concept. So that is not quite prevalent in India. That needs better infrastructure for development in a larger scale.
Okay, thank you, sir.
Thank you.
Thank you, sir. As we come to
Thank
the
you.
conclusion of the first session, we sincerely thank Dr. S. Albert Alexander, sir, for his informative and engaging session. On behalf of the organization, I express our heartfelt gratitude to Dr. S. Albert Alexander, sir, for sharing the expert knowledge with us. Your valuable insights are truly appreciated and will benefit us greatly. We truly appreciate your time and contribution, sir. Thank you so
Thank
much.
you. Thank you so much. Thank you all. Thank you.